Alright, so in section 12.5, we're going to talk about multiplying rational expressions. Remember, every time you see that word rational, you're just thinking about the fact that that's the word fraction. So we need to start with remembering how to multiply fractions. I know you do this differently now, but when you first started these, you started by saying, okay, 4, that's really 2 times 2 over 10. That's really 2 times 5. Times 25 is 5 times 5. And 6 is 2 times 3. And then you started looking for things that you could simplify. This is where that whole up and down diagonal stuff. So we could say 2 over 2 becomes a 1. But we can also say that 2 over 2 becomes another 1. A 5 over a 5 becomes a 1. And the only things left are 5 and 3. They do not become a 1, so we multiply across. 1 times 1 times 1 times 5. 5. Multiply across the denominator. 1 times 1 times 1 times 3. And that's where that 5/3 comes from. Now, I know a lot of you are in the habit of doing that problem by crossing stuff out here, right? You do 2, you do 3, you do 5, you do 5, except I should have said this was a 2. And then you say, oh, 2 over 2 becomes a 1. And that's how you get your 5/3. This factoring step is really what your brain is very good at doing. You don't even have to write this out anymore. Unfortunately, it's not going to stay that way for long. I think problems 1, 2, and 3 are very much like those other ones that we've done. So I'm going to write it out the long way for number 1, but in numbers 2 and 3, actually I'm going to leave number 1 for you. I'm going to do number 2 because it has both letters and variables. So in number 2, I said letters and variables, numbers and variables. So when we look at number 2, we take a 6 and we change it so that it becomes a 2 times 3. X squared is x times y, all over, that's a prime number, 5, x and y, times 15, that's 3 times 5, and x over 2 and a y. So now we can go ahead and do our divisions. Now remember, I'm going to do this in all this prime factoring, but these are still fraction multiplications. So with numbers, as well as with letters, that you really can go through and say, okay, 6 over 2, that becomes 3 over 1, right? Because 2 over 2 becomes a 1. And this 5 over 5 becomes a 1. X over x becomes a 1. Y over y becomes a 1. Remember, this 3 and this 3 do not simplify because they are both in the numerator. It has to be a numerator and a denominator, right? Something over itself, something divided by itself becomes a 1. So when I multiply across, I have 3 times x times x all over 1, 1, 1, 1, and a y. So that I end up with a final answer of 9x squared over y. Pretty confident that you can do problems 1 and 3. Give them a try, come back and check your work. So I'm pretty confident in your work on number 1, but I'm not so sure about number 3. So I wanted to make sure I pointed a couple of things out, and I did a couple of things a little differently on number 3. The first is that when I simplified something, and I tried to use a separate color to show you what I simplified with what, and I also wrote things all the way out, because chances are on your paper, it's not this nice and neat looking when you did it. The second thing is that when I thought I was finished simplifying, I discovered that I hadn't gotten them all, so I had an extra step here because I'd missed a pair. And then last piece is that when we list our variables, we always make sure we list them in alphabetical order for number 3.
Hi.
Hello.
Hello, man.